Hi guys, so today we're starting on our learning target on exponential functions. By the end of this learning target, you should be able to graph exponential functions, showing where their intercepts are as well as what we call end behavior. Okay? You should be able to model growth and decay using exponential functions, and you should be able to use exponential functions to solve application problems. So today we're just starting with an introduction to what exponential functions are. There are many things in this real world that grows faster as they grow larger, or they decrease slower as they get smaller. These types of phenomena, loosely speaking, we call it exponential growth and exponential decay if it's decreasing. In today's lesson, we're going to look at both growth and decay just to get you thinking about what exponential functions are. Okay? So let's start with this first example here. The number of people who have heard a rumor often grows exponentially, right? So let's consider a rumor, and it starts with 3 people knowing about it, okay? And where the number of people who have heard it doubles each day that it spreads. Okay? So first I want you to think, why does it make sense that the number of people who've heard a rumor would grow exponentially, right? So the reason why is because the person who knows shares it with people right, who in turn share it with even more people. Right? And it keeps on going and going and going. The people who know it share it with more people, who share it with more people, who share it with more people, and soon a bunch of people know about this rumor. Right? So here we're going to fill in this table below for the number of people. We're going to use the letter N to represent the people who know about the rumor, and we're going to use the D for the number of days afterwards. Right? So let's say when we first begin, 3 people know about it. Okay? 1 day later, okay, since it said that it doubles each day, right, that is why from the beginning to the next day, it multiplies by 2, and now 6 people know. Okay? The day after, it doubles again, so now 12 people know about this rumor, right? 3 days later, it doubles again, and now 24 people know about this rumor. Okay, the next day they tell even more people, it doubles again, and now 48 people know about this rumor. Okay, they keep going, next day share it with more people, and now 96 people know about the rumor, right? And it keeps going and growing and growing and growing. And as you see, right, in the beginning it might have only grown by 3 people, but then it grew by 6 people and 12 people and 24 people and so on and so forth. It keeps growing, and this is known as an exponential growth. So continuing looking at this example, right, we'd like to determine or find out the number of people who knows a rumor after 20 days, right? But to do that, we probably need to develop a formula to predict N. Again, N here represents the number of people who know the rumor, if we know D, the number of days it's been spreading. Okay, so for the following number of days, we're going to fill in how we can calculate our values based on what we call extended products using the number 2. Right? So when it first begins, the number of people who know is 3. The next day, we know that the previous number now doubles. The day after that, we take what we had before and double it again. And then without the parentheses, we can write it like this. The next day, we take what we had before, which is 3 times 2 times 2, and we double it again. And now, if we were to write it another way, it's like this. Okay. The next day we take what we had previously, which was 3 times 2 times 2 times 2, and we double it again. Okay. And so now, this is 3 times 2 times 2 times 2 times 2. Day 5, we take what we had the previous day, and we double it again, leaving us with 3 times 2 times 2 times 2 times 2 times 2. Right? So all we did is every day we took what we had and we doubled it. Okay? Then we take what we had and we doubled it. Right? Then we take what we had and we doubled it. Right? Then we take what we had and we doubled it, and so on and so forth. Right? So using this pattern you developed, right, we can write a formula giving the number of people who know the rumor if you know the number of days it's been spreading. Right? So here it was basically 3 times 2 to the first power. Here is 3 times 2 to the second power. This is 3 times 2 to the third power. This was 3 times 2 to the 1, 2, 3, 4, fourth power. This here was 3 times 1, 2, 3, 4, 5, 2 to the fifth power. Right? So here we know that the number of people who knows is 3 times 2 to the whatever days happened. Right? And so that's why here it's 2 to the first power because it was 1 day after, 2 to the second because it was 2 days after, so on and so forth. So using this pattern we developed in section A, we can write a formula that shows us the number of people who know the rumor N based on the number of days that has been spreading, D. So how many people would know the rumor after 20 days? So this means, what is N when D equals 20? Simple enough. Now that we have a formula, all we have to do is plug it in. Okay? So remember, order of operations, we're going to do 2 to the 20th first. So 2 to the 20th power is 1, 0, 4, 8, 5, 7, 6. Right? And so if we multiply that now by 3, this gives us 3, 1, 4, 5, 7, 2, 8 people. So that means in 20 days, right, if it were to continue following this pattern where it doubles, 3,145,728 people will know about this rumor, right? And this explains a lot of things in this world, right? You can think about viral videos, right, diseases spreading, right? A lot of things in our world follow this exponential function pattern, right? So as you can see, right, exponential growth can be very fast. From something that started with 3 people knowing and only 20 days after over 3 million people knowing, right, exponential growth grows very fast, right? So assuming our equation here from B holds that it's true, how many days will it take for the number of people knowing the rumor to surpass the population of the United States, which is approximately 315 million people, right? And so we can show calculations that support our answer, right? So this time here, this is our N. So I'm going to plug it into our N here. 3, 1, 5, comma, 0, 0, 0, comma, 0, 0, 0 equals 3 times 2D to the D power. So first I'm going to divide by 3, right? Because I want D by itself, I need to start with the furthest thing away from D. So if I take 315 million and divide it by 3, I end up with 105,000,000 equals 2 to the D power. Okay, and then we won't talk about it this year, but when you're in Algebra 2, you'll learn that to find an exponent, we use something called a log, right? And so what we're going to do is take a log. Since this is our base, it's going to be the base of our log, and then this will be what we have inside. And this will give us D, okay? Again, we're not going to learn about this year, but once you get to Algebra 2 in 2 years, you'll learn that To find an exponent, you use something we call a log or a logarithm. Okay, so I'm going to use my calculator to help me find this. And then I end up with, running out of space, I'm going to write it here, with 26.64 approximately 6. So approximately. Okay, so I rounded to 3 decimal places, right? So how many days will it take it to surpass it? So we're going to say it's going to take about 27 days, right? So that way it surpasses 350 million people, right? So that's crazy. Even at 20 days, we were only at a little over 3 million, but once 27 days hit, we're now at 315 million people, okay? So let's do another example now, but this time, we're going to look at exponential decay, okay? So we have a guy, his name is Helmut. He's from Finland, okay, and he's heading towards or walking towards a windmill in a very peculiar way, right? So in the beginning, he's 160 feet from the windmill, okay? On his first trip, he walks half the distance. Okay? On his next trip, he walks half of what is left, and each time after, he walks half the distance, half the distance, half the distance. Okay, we're going to model the distance using the capital letter D that Helmut has remaining to the windmill after n trips, the number of trips. Okay, so let's start again with the table below, okay, to show how much distance he has left. Right, so in the beginning, he is 160 feet away. Okay, he walks half the distance. After one trip, he's now 80 feet away, right? And what we did is we multiplied by a half. Right? Then he's going to walk half the distance of 80. Okay? So now he is 40 feet away. Okay? After 2 trips, he's 40 feet away. Then he's going to walk half the distance left here. So after 3 trips, he will be 20 feet away. After 4 trips, again, he walks half the distance. He is now 10 feet away, and so on and so forth, right? So here, each entry in the table could be found by multiplying the previous by what number, right? So if he's walking, again, half the distance, right? We know every time he walks half the distance. In order to find each of these numbers, we multiplied by a half. This is important to know when we're thinking about exponential functions because we always want to think about exponential functions in terms of multiplying, right? So previously we were doubling with our rumor, right? So we were multiplying by 2, but now each time Helmut here is walking half the distance, so now we were multiplying by a half, right? So like in exercise 2A, which we did on the previous page, we want to see this process repeated again using multiplication by half. And so we're going to fill out each of the following patterns. Right? So here, start at 160. After 1 trip, we did 160 times 1/2, which gave us 80. Okay? Then the next trip, we take what we had previously, 80, multiplied by 1/2, or also known as what we had 160 by 1/2 times 1/2. This gives us 40. Then to find the next distance, we do 40 by a half, or if we think back to what it was before, it was 160 times a half, and now we're multiplying that by a half, which gives us 20. The next time, again, we take what we had previously, 20, and we multiply by a half. But if we think about it from what we had previously, that basically is 160 times a half, times a half, times a half, and then we multiplied that by a half. So based on section C now, we can also give a formula that predicts the distance D that Helmut has left after n trips. So what you see with each of these is that it was 160, the original distance, multiplied by a half to however many trips there was, right? So after 1 trip, it was 1/2 to the power of 1. In 2 trips, it was 1/2 times the power of 2, right? We see it twice here. After 3 trips, it's 1/2 to the power of 3, right? Because we have 1/2, 1/2, 1/2 here. And after 4 trips, we see it as 1/2 to the 1, 2, 3, 4th power, right? So to find the distance, it's his original distance of 160 feet multiplied by half to however many trips he takes. Right? So how far is Helmut from the windmill after 6 trips? Okay, and so we're going to use this, right? So if it's 6 trips, we know that this here is n. So we're going to plug it in. D equals 160, his original distance, times 1/2 to the 6th power. And so if we do 1/2 to the 6th power, okay, the reason why I put this in parentheses is because we're multiplying 1/2 completely, not just 1, not just the 2, but 1/2. Right, so this gives me 1 over 64, which makes sense, right? 1 times 1 times 1 times 1 times 1 times 1, 6 times, that's 1. Okay, and then 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 again is 64. Okay, so 2 to the 6th, that's why it's 64. Okay, then 160 times 1 over 64 gives me 5.5, which we know is 2.5 or 2.5. Right? So that means after 6 trips, he is now only 2.5 feet away from the windmill. Okay. So Helmut believes he will reach the windmill after 10 trips. Right? He seems to be getting closer and closer. After 6, he's only 2.5 feet away. Okay, let's see if that's true. So if it's after 10 trips, this is n. So let's plug it into the equation we had before. So we're going to do our exponent first. Right? So 1/2 to the 10th power gives us 1 over 1024. Okay. We're going to multiply that by 160. That gives us 5 over 32. If we were to change it to a decimal, it would be 0.15625 feet. Right? So did he reach the windmill? No, he did not. Right? He's not going to reach it after 10 trips. Right? He is still, even though it's a small distance, he is still 0.15625 feet away. Right? So explain why Helmut will never reach the windmill. Right? The reason why is Helmut always only goes halfway. Right? So while his distance to it is shorter each time, based on the way he's walking, right, he never actually goes the whole distance, right? Helmut always only goes halfway. So while his distance is shorter each time, he never goes the full distance to reach the windmill. So hopefully that has helped you understand exponential growth and decay a little bit more. We will talk about it more in depth in the next couple of days. But that's it for today. Have a great rest of the day. Bye, guys.